Okay, and we're back, and you are probably thinking, I'm almost done with this class. And you are correct. You are almost done. If you've made it to week 13 of any MAT 205 online class, then you are definitely nearing the finish line. Okay, so as we get closer to the finish line, of course, things get kind of a little more crazy. Um, Lots of concepts this week. We're going to work with the quadratic formula and find out the difference between giving it an exact answer and a decimal answer. We're going to look at vertex and axis of symmetry, graphing parabolas, and then finding minimums and maximums, and then applying those skills in word problems. All right, so you see the quadratic formula. We're going to be talking about that in this video. Um, your quadratic equations hopefully will be given to you in standard form. If it's not given to you in standard form, then you want to put it in standard form. Once you get it in standard form, you'll notice you've got an a value, which is the coefficient in front of the squared term. You've got a b value, which is the coefficient or number in front of the x term. And then you have your constant, okay? And your quadratic equations should always be equal to 0. So these types of equations, if you were to graph them, they look like parabolas, something like that. They may face up, they may face down. All right, you might be looking for a minimum, you might be looking for a maximum, but the quadratic formula is actually designed to help you find two special places, and those are the x-intercepts right here. So notice that the equation is x is equal to negative b, so the opposite of your b value, plus or minus. The plus or minus comes in handy because you're usually looking for two different intercepts. One's sometimes positive, one's negative. It's not always that way, but sometimes it works out that way. Um, Here's your other x-intercepts here on that little parabola. Okay, plus or minus the square root of whatever you find underneath here, b squared, which is that number here, b squared minus 4 times your a value times your c value, all at the very end divided by 2a. So a is the coefficient in front of, or the number besides your squared term. B is your coefficient in front of, or the number besides x. C is the constant. It's usually hanging out by itself and it's not really attached to anything. All right, let's try doing the quadratic formula and see if we can get this formula to help us find these. These are called x-intercepts. Sometimes they're referred to as solutions. Back when I was coming through school, we used to call them roots. Okay, just depends on what book you're using. Okay, when they ask you to give an answer in exact, okay, that means you can leave your answer in radical form. Okay, so you don't have to go all the way down to a decimal. You don't have to reduce to a decimal. And we'll look at a couple examples of why or how this looks. Okay, use the quadratic formula to solve for x. All right, so this thing, we haven't graphed it yet, so we don't know what it kind of looks like. I can tell you that it's probably going to face up because that term right there is positive, and we'll learn that a little bit later. But what you're trying to flush out is where does this parabola, this touchdown looking thing, where does it cross the x-axis? Okay, so we're going to use the quadratic formula, but before we do that, let's make sure this is written in standard form. So standard form looks like this. All right, and it does look like it's written in standard form. So let's make a key for ourselves. What's our a value? What's our b value? And what's our c value? So your a value is always going to be that number in front of the squared term. The B value in this case is 9, and the C value is 2. Keep in mind, all of these are positive, 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 so you want to make sure you take the sign with you. So we don't have any negatives here, so we're just going to go with these positive 5, 9, and 2. Okay, now the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4 times A times C all over 2A. So what I like to do is draw this formula out, but anytime I see a letter, I'm going to put parentheses around it because I know I need to substitute a number in for those letters. So I always call this like a naked quadratic formula. So I got the negative sign. I've got parentheses open for my B value, plus or minus the square root of B squared. The minus 4 comes standard on the formula. We have to leave room for A and C and also leave room for A. So we're going to start substituting in. So it's asking for the B value here, so you're going to place the B value there. It's also asking for the B value there. Then it wants the A value, it wants the C value, and down here it wants the A value. So now it's not so scary. It kind of looks like it's order of operations is what we're going to have to deal with here. So let's refresh ourselves on order of operations. You always want to do parentheses and exponents first, then move to multiplication and division, always moving from left to right, and then finally addition and subtraction. Okay, so then just take this very slowly and just write out every step. That negative sign in front of that 9 is going to make it negative. Plus or minus is going to stick around. 9 squared is 9 times 9, so that's going to be 81. Okay, minus. So 4 times 5, we know is 20 times 2 is going to make that 40. And we know down below 2 times 5 makes it 10. So we're just going to kind of collapse this. So keep writing every time you take a step. So x equals negative 9 plus or minus the square root of. So 81 minus 40 is 41 all over 10. All right, we can't go any further than this. Like this can't be simplified. You can simplify it if the 9, the 10, and the 41 all had a number in common and you could reduce it, but they don't. So because they were asking us at the very beginning to leave this in exact answers, which means you can leave in radical or square root in this case form. Okay, we can give our answer. We've gotten to our answer, but this is how you're going to have to put it into ALEKS. All right. So it's really two answers. This plus or minus separates things. So what does this give birth to? First, it gives birth to negative 9 plus the square root of 41 all over 10, right there. It also gives birth to negative 9 minus the square root of 41 all over 10. So when you put this in ALEKS, you'll probably have to do it with like a parentheses, like negative 9 plus the square root of 41 over 10, comma, negative 9 minus the square root of 41 all over 10. That's probably how you're going to have to pop that into ALEKS. So these are two roots, all right, two solutions, two x-intercepts, right? Um, and I'm just drawing a picture of just a random parabola here, but this is potentially one root or solution or intercept, and that is the other one. So I have one for you to practice. So let me put this up here. All right, so here's kind of ones you can practice. So take a moment, think about whether this is written in standard format. If it is, you can pluck out your A, B, and C values. And again, leave your answer in exact answer format. So pause the video, come back and see me. Okay, if you're back, hopefully when you pulled out your A, B, and C values, you took the signs. So that's a positive 4, a negative 9, a negative 1. So if you go on Google, you can look up like how to memorize the quadratic formula. Some people sing it to like that song Frere Jacques. I am not going to sing it for you because you will see that I am a horrible singer. Definitely was not a gift that I was ever given, was to be able to sing. Okay. I'll spare you that. So then hopefully next you made a naked quadratic formula and then you started to put in your values. So we know B value goes in the formula twice, A value goes in the formula twice, C value is only used once. Okay, so I've been doing this for many, many, many years, and I can tell you that where people have the most trouble is underneath this radical sign. So I'm going to try to break that down as best as I can. Okay, what do we know about two negatives together in the night? Right, what's going to happen to that 9? Hopefully you know it's going to go positive. We know 2 times 4 in the basement is 8, so I'm just going to clear that up. Okay, negative 9 squared is negative 9 times negative 9, which should be 81. And then I like to do this kind of all at once in my brain, okay? And notice I circled the minus sign. So I like to do it this way because I can say to myself, negative 4 times positive 4 is negative 16. Negative 16 times negative 1 is positive 16. So I kind of go that route here. Okay, let's keep going. Let's keep simplifying. 81 plus 16, 97 over 8. Now, 9 and 8 and 97 have nothing in common, so we're done, right? This is going to be an exact answer. Here's how you're going to type it in. It's probably going to look like something like this on Alex. It's probably going to have an x equal, and then you'll simply go 9 plus the square root of 97 all over 8, comma, 9 minus the square root of 97 all over 8. So the plus is going to go here, the minus is going to go there. Those are the two roots or solutions or intercepts, all right, that you have gone and found those exact positions. We're going to leave it just like this, which kind of doesn't help you visually because you don't know where this is. I don't know where this is on the x-axis. I know it's somewhere. So that's why on the next example, we're going to go to giving your answer in decimal form. Okay, let's try one that they ask you to give you the answer in decimal form. Decimal answers. Okay, so this one has two little caveats to this. So first you need to simplify all the way. All right, and the second thing is, look at this. This is not written in standard form. So remember, standard form looks like this. They're trying to get tricky with us, okay? So you need to have your squared term first, then your term with your x, then your constant. And right now, you got your terms all over the place. So you are totally allowed to move the x over and move the 2 over. So because they're unlike terms, right, you can't put these together, but you can write them out. So 9x squared kind of leads the pack. Negative x comes next. Negative 2 follows. And now we're equal to 0. Remember, your quadratic needs to be set equal to 0 because you're looking for, see if I can make that clear as to why we do that. You're looking for those intersections, right? Those intercepts, those roots or those solutions. And whenever you have an x-intercept, like let's just put this as, this could be 3 comma 0 and this might be negative 2 comma 0, right? So one thing they have in common is they both have zeros for their y, which is why you always want to set them equal to 0. If you set your y equal to 0 theoretically, then that should help you flush out your x-intercepts. Okay, make your key, pause the video, and see what you can do with this one. Okay, if you're back, be careful that your 9 for your a value is positive. This is really a negative 1. That's the coefficient in front of the x term. And negative 2 is your constant or your c. Okay, and again, be very, very careful. This is where the errors usually happen, so don't let that happen to you if possible. What do we know about a negative and a negative? It's going to make that a positive 1. In the basement, we know we got 18. All right, negative 1 squared is negative 1 times negative 1, which is positive 1. And then I'm going to do this like I did the last one. Negative 4 times positive 9 is negative 36. And negative 36 times negative 2 gives us positive 72. All right, so positive 72 goes here. Okay, now let's go a step further. 1 plus or minus, this would be the square root of 73, 1 plus 72 over 18. Now we could leave this as an exact answer, but they don't want exact answers this time. Remember at the beginning they asked for a decimal answer. So they actually want to know exactly decimal wise where this thing sits on the x-axis. Where does it cross? Where are those x-intercepts? Okay, so I would, in my calculator, here's how I would do this one. Now everyone's calculators are different, but I would do, let me write this out. 1 plus the square root of 73 over 18. 1 minus the square root of 73 over 18. Okay, so do these in separate transactions. So 1 plus the square root of 73. I'd hit enter, divide by 18. And it looks like they want us to go out 2 decimal places. I was checking in Alex, so 0.53 is going to be one of my x-intercepts. Now I'm going to do this one. 1 minus the square root of 73 divided by 18. And if I want to go out 2 decimal places, this is going to be negative point, oops, probably can't see that, 0.42. So in Alex, you're probably going to have it out looking like this. X equals, and there's going to be probably a box. So I would put 0.53, comma, negative 0.42. So those are kind of icky roots or solutions, but they could be graphed like if we were forced to do it, right? 0.53 is somewhere between 0 and 1, and negative 0.42 is somewhere between 0 and negative 1. All right. And so your parabola probably is kind of skinny parabola, kind of looks something like that, perhaps. Okay. Hopefully this is helping because once you get used to simplifying all the way down to a decimal answer and you've had some practice, then they start throwing some word problems at us. So let's take a look at a word problem or a story problem. Okay, because you might be wondering, when are we ever going to use this? Well, you might be faced with a question like this. So says selecting a word problem using a quadratic equation with irrational roots. Okay, this just means you're probably going to have decimal answers and the decimals don't repeat. So they don't repeat or ever end. Now, we're going to have to make it end at some point, the answer, so we're going to go out 2 decimal places. So a ball is thrown from a height of 130 feet with an initial downward velocity of 6 feet per second. The ball's height h in feet after t seconds is given by the following equation. Let me write this bigger. H equals 130 minus 6t minus 16t squared. How long after the ball is thrown does it hit the ground? Okay, so remember h is height. Let's go look at this picture over here. T is time. So here's your height. Pretend you're up here and you throw, let's just say, that ball down. They want to know, when does it hit the ground? Okay, so my question to you is, what's the height? What is the height equal to when the ball hits the ground? Okay, what is the height equal to when the ball hits the ground? When that thing comes to a screeching halt and hits the ground, what's the height? Hopefully you're thinking that the height is equal to 0, right? You've hit the ground. So you're going to put 0 in for h. And then you can rewrite your problem out, your quadratic. Okay, notice it's kind of written in a weird order. Normally, we like it written as ax squared plus bx plus c equals 0. So it's kind of reversed, but you could still figure out that this is your a value, right? That's the coefficient in front of your squared term. This is your b value, and the 130 is going to be your c value. It's just kind of written kind of, backwards in a way. So we need to know how much time it takes once you throw that ball off the roof of this house, let's just say this building. What's the time? 1, 1,000, 2, 1,000, 3, 1,000, before it hits the ground. Okay, so we can figure that out because you can treat the ground as your x-axis, and this is sort of like a parabola here. So you're looking to see how much time did it take before it hit the ground. All right, so let's use the quadratic formula. So we have x equals, and I'm just going to do a naked one. Okay, so um, I'm going to say the opposite of b. Well, my b is -6, plus or minus the square root of b squared minus 4 times a, in this case, is -16. 4 times a times c, c is 130, all over 2 times a. All right, let's do this. X equals 2 negatives, going to make that 6 a positive. I'm so lazy. I always go to the basement first. 2 times -16 is -32. I want to do that before I have to deal with this unpleasantness. Now, -6 squared is -6 times -6, so we know that's 36. Then just be very careful here, right? -4 times -16. Well, negative times a negative is going to make a positive. So what's 4 times 16? That's 64. So that turns into a positive 64 times a positive 130. 8320. Okay, and it's all positive. Now I need to add 36 to the 8320. And I'm going to get 8356. All right, so I'm going to come over here because I need a little bit more room. X equals 6 plus or minus the square root of 8356 all over -32. Okay, well, let's see if we can drill this down to find a decimal answer. We know that there's two solutions, roots or x-intercepts, and you'll see that one of them is something we're going to throw away, we're not going to use, but the other one we will. Okay, so this can be written as 6 plus the square root of 8356 all over -32. It could also be written as x equals 6 minus the square root of 8356 all over -32. Okay, let's go to the Batmobile. 6 plus the square root of 8356. I'm going to hit enter. I'm going to divide that by -32, and I'm going to get -0.3044. Now, I'm going to go out 2 decimal places because they're asking us to go to the hundredths place. So I'm going to go -3.044 as one answer. Okay, I'm going to do 6 minus the square root of 8356 and divide that by -32. All right, and I'm getting positive 2.669. I'm going to call that 2.67. 2.67. Okay. The question is, how long after the ball is thrown does it hit the ground? Well, have you ever seen time be negative? And the answer is no. So we just found that time is really equal to 2.67. This x is really t, if you recall. So once you're standing at the top here, you throw the ball off and you count 1, 1,000, 2, 1,000. Before you even get to 3 seconds, the ball has hit the ground at 2.67 seconds. All right. So hopefully this is going to give you a good start when you jump into ALEKS and you work on these quadratic equations. Next, you'll be asked to find intercepts of a nonlinear function. So, of course, this is a parabola. It's not a line, so it's nonlinear. And I like these because if you're a visual learner, you can clearly see the answers to this. I think these are great. The problem is my screen is terrible. Okay, give all x-intercepts and y-intercepts shown. All right, so we want to find our x-intercepts and we want to find our y-intercepts. Okay, let's start off with the x-intercepts. We know it crosses here and here, and you might not be able to see it, but this is 1, 2, 3, 4, -1, -2, -3, -4. So it crosses at -2 and 2. So those are our x-intercepts. It does cross the y-axis at -1, -2, -3, -4, right there. And that's all we're looking for. All right, where does it cross the x-axis? If it does, where does it cross the y-axis? If it does. So you want to name those locations. Let's try another one where they kind of ask a little bit more. And this will be the last question in this video. Okay, find the vertex, intercepts, and axis of symmetry from the graph of a parabola. Okay, let's start off with answering question A. Does the parabola open upward or downward? So if this looks like somebody doing the touchdown, right, then this is going to be opening upward. All right. If it looked like this, then it'd be facing downward. Okay. Where is the vertex? The vertex is either going to be the minimum or the maximum. If your vertex faces up, excuse me, if your parabola faces up, you're going to have a minimum vertex. If your parabola faces down, you're going to have a maximum vertex. So minimum, maximum. This one faces up. Okay, so the vertex is the point where this line is going to come down, excuse me, this parabola is going to come down. It's going to hit that point. It's a turning point, and it's going to bounce off that point and go back up. So this right here is called the vertex. It's a turning point. So it happens to be happening at, let's find this coordinate here, 2, -4. So the vertex is 2, -4. That's the turning point. Okay, the axis of symmetry is what cuts this parabola in half. So I'm going to draw you a vertical line. This is called your axis of symmetry. It divides the parabola into two equal halves. So this is actually a line. And we learned last week that lines that are vertical that cross the x-axis, we just name it x equals wherever it's crossing. So x equals 2 is our axis of symmetry. The last question says find the intercepts. Well, does it have some x-intercepts? It certainly does. We can see one here at 6 and -2. Notice I'm not putting parentheses around this. It's just -2 and 6. If you were to put these in coordinate form, it would be -2, 0, and 6, 0. But they're not asking us to put it in coordinate form. Just give them exactly what they want, the points where it crosses the x-axis. Where does this thing cross the y-axis? Right here at -3. If you were to give that in coordinate form, it would be 0, -3. Okay, this concludes our video. I'll see you for the next one in, I guess this is week 12 we're in. Yay!